Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to the first ever Data Services Office Hour featuring data scientists. Holy smokes, what's going on? Smart people early in the morning. So I'd like to welcome two new faces to the channel, Sophie Watson and Chris Chase. Sophie's favorite algorithm is linear regression, and Chris Chase is in love with dogs, apparently. And has treats for his doggo in his desk. I've never thought of doing that, but I might in the near future. So please introduce yourselves for the audience, everybody.
Thanks, Chris. Hey, I'm Sophie. I'm a data scientist. I guess the past kind of 4 years I've been working at Red Hat, and we've been thinking about, how can we make data scientists' lives easier, and how can we make their Kubernetes and OpenShift experience fantastic?
I'm Chris Chase. I'm an application developer by training. And for the last couple of years, I've been trying to take all the good work that data scientists do and incorporate them into different applications using lots of different methodologies.
My dog just decided to strut in. So now she laid down in the doorway. Never mind. Sorry. So for folks that don't know, my dog is a German Shepherd Corgi mix, and people always want to see it when I say that. So yeah. So we were talking before the show, and one of the topics we were covering was, there's a lot of AI, there's a lot of ML, there's all kinds of things happening out there, but those models are hard to get into applications or actually running in production, as I call it. And I spent some time in the research land in my career in DevOps, and I know the struggle of that researcher trying to get their model into an application actually working kind of deal. So the idea here is to kind of help you, the audience, whether you watch it now live or later, better understand like how you can integrate your models into your applications and actually get all that working together so that your actual work can go to work for your customers or your organization, for example.
Right.
Yeah. Talk more, Sophie, please.
Well, I think that, the thing that we've got to remember is that data scientists aren't application developers or infrastructure experts or Kubernetes experts. We don't get excited about running things on X platform versus Y platform. We just want to go off and train that machine learning model, explore that data, and do what we're comfortable with. And although there's programming involved in that, we're certainly not, application developer level of programming mastery. So I think in general, data scientists work in a way which is not conducive to getting that machine learning component into a larger intelligent application. And so that usually means I just do my bit. I'm like, yeah, I've got a machine learning pipeline. I've trained a model. I'll just flow my stuff over the fence to Chris, who gets very...
Yeah, and usually when I get it, this is not Sophie, by the way, but just like sometimes from a data scientist who hasn't worked in a software engineering firm before, or, they're used to staying in that Jupyter notebook all day, every day, and that's kind of their world. And so they say, hey, I've got this awesome working model that does X, Y, Z. Here you go. Here's this notebook where it totally detects whatever I want and it totally works. I'm like, fantastic. And then the first time I go in there and I try and get it working, like, like sometimes their cells don't run in order. So they've gotten you ran 6 and then you go up to 4 and then you go run it again and it'll load properly. And then usually for the app, all I want is like the prediction, like, cause I'm not going to train in my app. Like that's a long 3-day async process, right? I just want to know if this thing if this 5 is a 5, or if, this linear regression, what it's going to spit out, what this prediction is. So I just want that prediction, and I just want its dependencies. I don't need all this exploration and, training and all this other stuff. I just need to find that like one function and its dependencies. But that's not what I get. I have to tease that out. And it's really hard to do that. If it's
dependencies is a good one as well. You mentioned there, Chris,
like what all dependencies would come with a trained model?
So
Talk to me about
that's
that.
so my favorite is when a data scientist has been working on his local machine
Mm.
and he'll do a pip freeze. He's like, here's your dependencies. And it's literally every dependency on his computer. It's just like, oh,
No virtual
God.
environment, no nothing.
What am I doing to do?
Yeah, like, so like for the data scientists that are out there, I mean, Sophie, you've kind of, I think maybe learned this, working here just through your normal, career, that you can't just hand over an entire environment to an IT team or, somebody that's running stuff in production and be like, here you go. Like there's a process that we have to follow to get it into prod, and downloading the internet's not part of it usually.
Yeah, I think so. I think that's true. I don't want, data scientists to look at this and think, oh gosh, I've got to change everything about how I work and I'm the problem here. Because that's, it's just a completely different skill set and a different appreciation for what it takes to put something into a larger application. And I think at the end of the day, as data scientists, we want to find the insights in the data, and we want to share that with people. We want to be as useful as possible. So the way that we've been kind of approaching it here at Red Hat is to try and teach some DevOps best practices to data scientists. So still allowing them to work in Jupyter notebooks, not assuming that we're trying to turn data scientists into application developers, but just trying to, educate on what it takes to put something into production. No one teaches you about dependencies when you go to data science school. Data science class isn't like,
I would imagine not. Yeah.
Right. It's like, this is the log loss regression function for the third level of your 7,000 level neural net, and if you integrate this, then you're good. And like you never use that in a day job. I'm sure someone somewhere does, but
right.
The kind of the practical engineering best practices, I think we as data scientists can learn a lot from.
Yeah, I mean, just something like putting it in a container is like a huge win, normally.
I think that's true, but if you tell a data scientist, "Oh, just put this in a container,"
right? Like you have to get them there first.
Why?
Yeah.
But also, why should they care whether or not it's in a container?
Mm-hmm.
So it's kind of like, well, if it's in a container, it's more repeatable, it's more portable, it's more scalable. All of the benefits of containers, when they translate beautifully to machine learning and data science models and workflows and pipelines. But at the end of the day, I don't want a data scientist to have to write a Docker file.
Right. And that's the thing where like IT teams and your DevOps or SREs or, all the people and functional parts of your pipeline of getting applications to production come in and say, hi, let's work together on this so that we can make something usable for all. Right. So teamwork makes the dream work in this sense, like for sure. Like, sorry to be cliche about it, but it's, in my experience working with, data teams, it is all about like, hey, I can build you this thing to help you make this more portable. Just run it like this, and you can put anything in it you want and it'll be fine. And giving them the context to do that helps tremendously, as well as, any guiding points and kind of being their help desk, for lack of a better term. Like that is definitely necessary.
Yeah, and I don't think we're asking too much from the data scientists. Like we don't even really need for them to understand containers even, right? Because if they just give like if they just are able to separate out their functions, write a Python function, which they know how to do very well. Yeah. If they understand their dependencies way better than the app dev is gonna, right? It's like, I need this version of TensorFlow and this version. Like that's really all we're asking is just know it's important for that app dev to take your work and take it to that next level.
Right. Yeah. Cool. So we do have something we can show off, I'm assuming, right?
Yeah. If we're up for it, I mean, we can show you what this kind of process of getting machine learning into an application is looking like at the moment on OpenShift. So we can use Red Hat OpenShift data science for the data scientist environment. So you'll be able to see that that's kind of, it's what a data scientist likes. It's got the tools data scientist likes, it's the environment they like to work in. And then I think Chris is going to impose some structure on my work.
I mean, we can start off with a little project here, I guess, if you want to see like what I would kind of need for you to do your work in so that we can like take it to the next level. Here, let me show a little, like a sample project, I guess. Is that all right?
Yeah, whatever you want. It's cool.
So here is like the most dead simple thing I can think of, because like in OpenShift, we have S2I, and the data scientist has their notebooks and stuff. And so there are a bunch of really complex methods of getting data science work. And, we can cover that, I think, in the future with like CI pipelines and, servers like Selden and KF serving and stuff. But really, we could just, the two of us could still get our work done just by using OpenShift and like Jupyter Notebooks and the OpenShift data science platform. So here you can see this little template, which would make that easy for a data scientist like Sophie to get started. It's got some notebooks here for her to get started. And then when she's done there, she can just take out her prediction function and put it in a Python file and take out the necessary requirements for her her prediction function and put it into the requirements.txt. And if she does that for me, like I can take this already builds because it's already got an application file in it, really a very small application file. So we could just like use this template, create a new project out of it, right? And then like, she's ready to go. I'll give this Git repo to her and this will function as basically storage, version control, and it'll notify OpenShift that, hey, you need to rebuild and redeploy. So it's doing some heavy lifting there, but it's real simple and there's almost nothing to it. As an application developer, I'm already used to using S2I on OpenShift, and she's already used to using her notebooks and writing Python functions.
Right. Cool.
So it, like I said, dead simple, and I would give that to the, a data scientist to go ahead and get started writing.
I think by starting with already a discussion between the data scientists and the app dev, like, right, this is how we're going to serve the model. So this is what we need your work to look like. This is what the end goal is. Right. It's nice. It makes me think that, maybe my model will deploy this time.
Well, yeah, and pride in your work is everything, right? Like going back to dimming, having pride in your work means if you're a data scientist, you want to see your models out in the world, right? Like that's going to give you the most pride and make you feel the most fulfilled, which we all want to kind of, feel like we're being productive at our job, I hope, and having that desire to get your models out there. I understand that. I feel that for a lot of people because I often feel there's this wall of confusion that sometimes data gets thrown over and it just doesn't work out somehow. And we're trying to, educate people so that it can work out. So the show is for our ops people and our data scientists and our app devs all together, all in one.
Team. So cute. Okay, so I will go ahead and show you what. Let me see if that works. So hopefully you're seeing, sweet. So I'm in Red Hat OpenShift Data Science. So this is a managed service. It's running on top of OpenShift dedicated. Nice. And it's an environment that like has all the data science things. So I don't have to go to the OpenShift console and look at all those dashboards and find a route or a route, as you North Americans say, and expose it and then go,
you can say dirty Americans, that's fine.
Would never. So this is Red Hat OpenShift Data Science. You can see that the only thing we've got enabled here at the moment is Jupyter Hub, because that's all our admin has put in our cluster for us at the moment, but there's a load of other stuff that, you know, you can add into here. So like Chris talked about other ways of serving models, you know, we could be using a pipeline. Maybe we're using seld and deploy to serve and manage and monitor those models. So that could all be integrated. I think later we're going to hook up to OpenShift streams for Apache Kafka, right, Chris? Maybe.
Sure. Yeah. If we have time, we can do that.
All right. That's exciting. So I'm going to launch Jupyter Hub, and we can see all these Jupyter notebooks that we've been talking about. So completely self-service for me as a data scientist. I can get my environment. I can set my container size. I've got my AWS secrets in there so I can access my data. And I'm going to start my server.
Ooh, fancy.
The suspense. All right, so now I'm just in, you know, standard Jupyter Lab environment. You know, I could launch a notebook and start coding in here. I'm not gonna because Chris set me up that Git repo. I actually forked it and already put a load of stuff in it. Otherwise, this would be a very slow, very boring hour for everybody whilst I typed some slow Python code. So I'm gonna copy my fork of that and come and clone it into the environment. All right, so I know we've been talking about Jupyter notebooks. Like if you haven't, maybe you haven't used them before, maybe you haven't had the absolute delight of trying to interact with them and see them, or being sent one and trying to get it to run. This is what they look like. So it's essentially like a real notebook. It's like you can just put all your thoughts down. It's a combination of prose and markdown and code. And you can actually execute that code in line, and then the output is printed below. So here you can see we've got these, you know, standard Python imports, and then we're asking it to print out the TensorFlow version. So I know we've talked a bit about dogs. Chris, you've got dogs as well, right?
Yes.
And other Chris, you've got dogs as well, right?
I do. Franklin's here, actually. Maybe we'll try out your model on this dog here.
All right. So what we're going to do today is just, we're going to use a pre-trained model for object detection. I think I guess the thing I want to emphasize here is that a lot of machine learning models have already been trained for you and are good enough for the job at hand. There's some use cases where you're doing something completely new and pushing the boundary, but in general, there's things out there. And we want to create a cute little dog detector app today so that we can, you know, point our camera at dogs and confirm that they are dogs. I know there was questions earlier about whether dogs are actually humans.
I mean, mine does act like a legit human. She has human-like needs in the whole 9 yards. Yeah. Several words that she understands in the English language and the whole 9 yards. She's ignoring me though, so
no,
that's typical.
Hopefully we get to see her later.
Hopefully she might come in here. She's like right outside the doorway to the point where it's like obnoxious to go grab her.
No. So cute. So yeah, we're going to put together an object detection app that, you know, you can show a photo of a dog and hopefully it will tell you, yes, there is a dog, and you can show a photo without a dog and it will say there's no dogs here. So in order to, you know, start this and test this out, I'm going to need a photo of some dogs. So I'm using Max and Margot here today. This is Max, this is Margot. They live in Bristol, England. They're very good dogs.
As all dogs are.
That is true. And so I'm using TensorFlow as well. So TensorFlow is like a standard library that's often used for image processing, which is what we're doing here because, you know, machine learning models can't actually take in a photo. They don't know what to do with that. So we're using TensorFlow, turn this into a tensor. which is something more that our model can understand. I said I'm using a pre-trained model. So there's like, these image detection models are good and they're very big. So to train them yourself, you'd need tons of data and you'd need tons of time, a load of compute power. And there's just no benefit when someone's already trained a model on dogs for me. So we're using this SSD mobile net data model, and it's been trained on Google's Open Images dataset. So it's got 600 types of objects it can detect. Now we just want dogs in there, so we'll deal with that later. But yeah, we load in the model, we pass it in our tensor here, and we can go ahead and ask it to detect, and it spits out all of this code, which is essentially telling us the objects that it's seen in this image, how likely it thinks it's seen them. So this is, 85%, 79%. These are much smaller. So it's not very confident that it's seen whatever object it thought this might be. Maybe some more classes corresponding to the type of object, detection boxes. So this model is going to put a box around the thing in the image to show us where it is. And finally, the moment of truth, the things that it's actually predicted. So dog, footwear. And so for each of these, we've got a detection box. So we're going to be able to impose those back onto the image so that we can see. So we can go ahead and draw bounding boxes on our image containing those predictions. And okay, we've got a dog here. We've got a dog here. The font isn't very clear, but I can tell you that it thinks that their paws are footwear, which I think is really adorable.
That is adorable.
It is, but for the purpose of today, we just want to detect dogs and not footwear. So there's a couple of things we're going to do. We saw that, first off, the model was making predictions that it wasn't very sure about.
Right.
So we're going to filter all of those out. We're going to put a threshold in and say, hey, if you're not at least like 30% sure about this, then don't wake me up in the middle of the night to tell me that there's a dog outside that I can go and pet. Like, I don't want to get out there and it's actually, a raccoon. That would be,
or
possum
or something.
Yeah.
I like the gnarly stuff.
Yeah.
Or a coyote. Could it tell the difference between a coyote and a dog? That would be fun.
I don't think I know what a coyote is, but we
can
test it out later.
Okay.
Yeah.
It's more than Looney Tunes. I'll just leave it at that.
All right. And then the other thing we're going to do is filter out any predictions that aren't dog, because we only want dog. So if we're only going to get this app to identify things that are a dog and that we're sure are a dog. So we go ahead and, encode that here. If label equals dog and score is greater than 0.3, nothing too extreme going on. And now we just got our dogs and no footwear. Fantastic. So, Chris, I'm basically done, right? I'll just throw this over the wall to you and tell you, put it in an application.
Right.
Do the thing.
So right now is actually usually where I end up getting it. But that's why we had that definition earlier of like, hey, could you separate out your prediction function into its own Python file, right? Because you don't want me fishing through that and trying to figure out what is important because I don't know. And I'm going to break her code. Like I have no idea which function is important. And the same thing goes for dependencies. I don't know if TensorFlow is just for her training or if it was going to use in all of it. There's a bunch of those. Matplotlib is probably not going to be used for my prediction function, right? So if she puts that requirement that I'm going to need in the requirements.txt, and she puts that prediction function in a prediction file, that'll keep me from screwing up her code, and I'll be able to incorporate it that much easier.
Nice.
Stuff like Boto3 that we use to connect to S3, standard Python library to connect to S3, which is where my dog image was stored. Like Chris doesn't need that because Chris is going to be trying to predict new images that are taken on the app. He's not going to be connecting to S3 buckets. So let's start with the requirements. Chris, tell me about these first three.
So I added that to the template. You know what? I should have put a comment in like, this is mine. And this is yours. So that's my bad. I probably should have done that. But 6 below is kind of her dependencies for like the data science stuff. And up there was my application dependencies, right? So we're kind of keeping them separate. And
Mhm.
so that'll allow me to change the application up and work while she's changing her data science without messing with each other too much.
Nice.
Sweet. And then this notion of putting the things that we need to make the prediction in the prediction.py. So our notebook had everything in. It had, let's look at an image. Let's see how we turn an image into a tensor. Let's look at all the output from our prediction. Let's plot all the bounding boxes, including footwear. Let's now amend the code a bit. Okay, now we can see that we can just detect the dogs. So there's kind of a load of stuff going on in there. It doesn't look like Python code that you would want to share with the class, I guess. It's a communication tool. It's a nice story. You can see like how my brain was working and what we were doing to get to the result. I think it's really good for, teaching, learning, understanding, but it doesn't make for an application. So in this prediction.py, we've just got all of the things that are important for doing the prediction. We've got 3 functions in here, and that's all you need, right, Chris?
Yeah, and that is so much easier for me to read and get started with than going through all that exploration stuff in like the notebook, right? It's just gonna, like, I can pick it up and go. Yeah, and I can show you that actually.
All right.
All right, let me see here what I got. So let's see.
Are you finding the mythical tab that you want?
I am not finding the mythical tab. I am just terrible at this. What is
It's okay.
on?
The UI.
Can you see the dog
sharing
detector
needs
service
help.
screen?
Yes, we do.
Okay, yeah. So you can see this is her project that she uploaded, and it's got her new prediction file in it. Which is what we wanted, right? It's got her requirements in it. My application file was ridiculously simple. This is kind of a dummy project. It just calls her prediction function, right?
Nice.
And this is a buildable S2I project. Like, it started off buildable. Like, she didn't have to do anything, and I could have built it right away, right? So we were already ahead of the game.
So if you don't know what S2I is, source to image.
Source to image, which is really nice. So I'll show you what it does. So your OpenShift can just read from that Git repo and create an application from it. So let me go to the developer screen and show you how easy that is. I mean, this is really good for development. I wouldn't use it for obviously production systems, but it's really nice for iterating on it, right? If she pushes up a change to Git, or if I push up a change to Git, our service gets automatically redeployed and we can take it and look at it. And so this here is my little app that I'm going to connect to her service. Right, so let's go ahead and create her service here. So we'll create a new S2I from Git. We'll put in the Git repo, if I can find that. So it's already going to automatically detect it's a Python application because that's what it is. Right, we'll go ahead and create a new separate app for this, the dog detector service. And then so my app will call into the dog detector service and request some predictions. Now there it is. So it's building now. So it's going to automatically build from Git and create a containerized deployment and put that in OpenShift for my application to call. And my application is already configured to know where that is. While that's building, because it takes a couple of minutes. Now I wanted to automatically rebuild every time she pushes up a change to her model, because her model is going to get changed quite a bit as we test it out in the real world and see that coyotes are coming back as dogs, right? We're going to want to retrain that model to leave out coyotes or give you some special super alert. So that's really easy. Since we're using Git and S2I, we'll just copy the URL here for the GitHub webhook, and we'll go ahead and create a webhook into the dog detector service. So we'll do that, do JSON, and that's pretty much it. And so every time she pushes up a new model, that build will go ahead and rebuild and redeploy, and we'll get a new deployed service that my app will call. And so every time she updates her model, we'll see that live. So let's see how that app works real quick. Let's see. All right, so here's my little app. Hey, Frank, look, come here, buddy. Come on. Come here. There, buddy.
science school is
Yeah.
how to use Git. I had never used Git before I started working at Red Hat, and I remember that first week was quite something. I think there was a lot of need
Well,
for
if it makes you
Git
feel
blame.
better, if it makes you feel better, my first time, like this is a long time ago, but switching to Git from other version control, I swear to God, I think I screwed up for 6 months. Like I think I forced push to master, and oof, I never heard the end of that for like the rest of that job. So
Okay. Yeah, I think I mean the thing about this is that it's like because you set up that repo for me, all my files were already there. I just had to edit them. Kind of, it feels like it makes it a bit neater. And then the benefit of working with an application developer is that if I do something tragic on Git, which doesn't happen anymore, but it definitely has, then I can just call you up and say, Chris, wait, what
although I will say, no matter what happens, if it's Git or something else, I do hope that data scientists save versions of their old stuff. Like I have been in that situation. It's like, oh, hey, can we get that model? And he's like, I don't have it anymore. It's like, it was in my Jupyter Hub notebook over there, and I don't know what happened to it. I can't get it working again. That has been frustrating for me too.
Yeah, and I think not just I mean, for me, it's not just the model as well. You know, we talk about the model as being like the entity that's but it's really like, it's a whole pipeline. It's what data trained that model. If we think about getting these stuff into applications, then you've got to add that extra discipline of like, you know, this pretend that everything you do might be audited. Hey, which model were you running on date? You know?
Yeah. And the notebooks are super important for that too, because that was the notebook usually sometimes they use to train that model, right? Like that they can reproduce that model as long as they have that notebook still there. So yeah, saving that stuff is super important.
Yeah. I think that's true. It's also the case sometimes that, you know, with notebooks, you're never able to reproduce the model because, you know, we were talking earlier about running all the cells out of order and kind of, you have to impose some discipline to know like what happened, where things came from, and how to keep going.
But like by, you know, separating out your prediction and your requirements, like I could totally change that app without making you do anything. Right. So, I mean, is Chris still here? Yeah. Do we have time to show? I guess we could show Kafka. Like we could change that app up to use like a Kafka queue instead.
Yeah, let's go for it.
Okay.
Hey, Bobby, how's it going?
Yeah, sorry everyone. Chris is having internet issues right now, so I'm not sure if he'll be back, but please continue the conversation. Sure. Great.
Let's see. All right, we'll pick up where we left off. So right now, this app is fun, but it only like works whenever you are clicking on it. So if I want to do a monitoring service, like if I wanted to monitor something outside for coyotes or for dogs or whatever, to make sure, you know, if it gets on a zone, I'd need to be notified about that. So let's see. So let's go ahead. So instead of doing a single snapshot and uploading it, let's go ahead and like put a constant stream of images onto a Kafka queue, read that Kafka queue, and then do the predictions on that Kafka queue. So I went ahead and made a Kafka queue called object detection, right? And it's going to take the images, do the prediction, and put the objects on this other queue. And then I can read from that objects queue and see if anything was detected. I can read those predictions, right? And so hopefully what we'll get is we can put up a camera and it'll take that stream of images and it'll run the prediction on those images. And like I said, you've already done your part. My goal is to redo this app without you having to do anything, right? So, let's go ahead and see what I can do. So go ahead and open up a Jupyter Hub app of my own. So just like you did S3, I'm going to go ahead and talk to this Kafka queue. So I need to get the connection information and get that here. All right, and that will go as one of my environment variables, which I'll use in there. All right. So I'm going to go ahead and spawn my app. And this is just to show how easy it is to work with Kafka. You can do it from inside a notebook, and then we'll just change this app up a little bit. All right, so we'll go ahead and do a new project, a new service, a Kafka consumer, which we'll go ahead and use from inside Jupyter Hub, and we'll see what that looks like. All right, so this is a Kafka consumer, which will read from that second queue. So we'll go ahead and get it working here. So you can tell I've installed the Kafka Python library. I've read my server information. And this is me creating a consumer that's reading from just a notebook test queue to see if it works. So it's subscribed. And then here in another notebook, you can see, go ahead and just send some messages for it to read. So this is a producer, right? So this is going to put messages on that queue. And so my app was going to go ahead and read the images from one queue and then produce a new message on another queue. And you can tell this one is sending some hello messages. And this one is going ahead and receiving those and consuming those. So we've got a consumer and a producer worked out. All right, so let's go ahead and change that app. Instead of doing the REST service we did before, we'll just go ahead and create a consumer to consume those images that the app is feeding into Kafka, and then we'll produce the predictions on there. So we'll just do a prediction and just stick that on that other queue, right? And so you've already got, your prediction hasn't changed. It's still exactly the same. The requirements, your requirements are exactly the same. Mine, I just changed to use Kafka Python because it's a Kafka Python consumer. So we can go into the app again, and we can create a new service. The same way we did for the dog detector service, we can create one for this application, right? So we'll go ahead and create from Git, the same one. Right. Right. And then I'm going to have to put my Kafka information here in my deployment environment variables. I'm going to go ahead and hide that from you on my screen because I don't want to have to show you my password real quick. And there we go. So now instead of just talking to the REST service, I can go ahead and talk to this Kafka consumer. And I can, the Kafka consumer is going to be talking to Kafka, and it's going to be adding messages onto that queue, which my app is going to pick up. And once that's done building, the same way like the other thing, it's really the same thing. We can take a look at what that does. All right, let's see this work. This is on video mode. It's going to push up an image every so often and see if that works. All right. All right, so if you're walking across my lawn or my flower bed, dog. So the nice thing about this was like the app has totally changed, but Sophie didn't really have to hardly do anything at all, right? And just by that little bit of structure up front, that, that lends itself to me being able to change everything without having to bother her over and over again. She's got her prediction, she's got her requirements, and it's really easy for me to pick up and move with it.
That's
That
awesome.
was about it. But yeah, so all this transition from data scientist to app dev, I feel like you just talk a little bit beforehand, you get a little structure, you find out what I'm going to need and what she can, do. Just makes everything so much easier.
The shared understanding, the shared knowledge, right? Like that's what DevOps is all about, right? Like helping others succeed, I feel like is everybody's role in DevOps and ops in general, especially application development, right? Like we should be helping each other. And your dog's still in the background looking at you like, why aren't you letting me out? Just want to point that out. Shout out to my dog. So yeah, like this was an amazing, kind of handoff process that we just witnessed. Sophie did the work, trained a model, handed it over to Chris, some shared understanding about what things are needed, and Chris implemented it, for lack of a better term. So this is the dream, right?
And it's not prescriptive. Like this is just kind of what we did. And this is a really easy way for us to do it between an application developer and a data scientist, right?
Right.
There are lots of great ways with, CI and pipelines and stuff that we can do if we have go a little bit further and have a little bigger team. But this was drop dead simple.
Exactly. I think that's the advantage of it.
Right. And there's also like so many other frameworks that we could build into this. Like, Chris, you wanna
Like you're talking about pipelines and serving models, or
yeah.
Yeah.
And
I think we should cover some of that in the future. I would like to, because like your service, like I used, that was a custom app, and trust me, there are a lot of people deploying models in custom Flask apps. That's why that exists.
Right.
That seems to be, but there's, you can use something like Selden, which gives you drift detection, and it has all kinds of monitoring. What else does it give you, Sophie? I can't think of off the top of my head.
yeah, just like explainability services. It kind of automates that rollout of new models. You can route some of your traffic to new models, some to old.
Right,
models.
canary deployments and stuff.
Yeah.
Yeah, and it's pretty easy. Like you can just tell it where your TensorFlow model, that serialized model is, and it'll be able to deploy it. So it's real nice and easy. We can cover that. And then for the building of the model, sometimes you want it to automatically build or build outside of a notebook. And so people will use like, a pipeline of some sort, whether Tecton, Kubeflow pipelines, Argo, whatever it is, people will build those things in all kinds of ways. So I think there are all kinds of possibilities, whatever's right for your team. But definitely in the transition from data science to app dev, it's really nice if the data scientist knows upfront what to make.
Yeah.
Awesome. So if you were, somebody that had just watched this and were, and like you're a Sophie, you're training models and such, do you think going to that app deployment team and saying, hey, or app development team and saying, hey, do you feel like you've given people enough to go with here to take to those teams and be like, hey, we can work together, right? Like somebody has to reach out and build that bridge, and it's not always going to be the operations team or the app dev team, because oftentimes they have their head down. But if the data scientist needs the model in prod, how would you build that bridge?
I mean, I think the process you can work out ahead of time. Yeah, that's a hard thing.
Right. Like, at some point in time, you need to have like a sit down with, representatives from all sides to kind of say, hey, this is the goal we're working towards. How can we facilitate that as a team?
Right. I mean, you kind of have to have what everyone, because it also depends on skill set, right? So if you like, how much is that data scientist willing to take on? Because there are some data scientists who feel pretty comfortable actually in Flask and this, that, and the other thing, and they don't mind understanding some of that. And there are others who don't want to touch it. So,
right.
So I think there's got to be an agreement between teams, like, hey, this is what we can produce. You guys can pick it up from that point onward.
Right. Like the handoff, the takeover point. Yes, absolutely.
Right. And then you can try out a different product and see what works for you, whether it's, KF serving, Kubeflow, or custom apps,
Awesome.
And I think just like, a real understanding from kind of the ops side and the app dev side that a lot of this is outside of a data scientist comfort zone. Like, if there's data scientists that are watching this, they're just starting out, or, in school learning data science, like nobody seems to teach you, you said like package control, that library control, like you do just work on your computer and install every Python library into the same environment. Like no one, the kind of the architecture and the engineering stuff is like definitely a completely new level. And I don't know, I hope people see that like you can learn as much or as little of it as you want. You don't have to become an expert. Like we're not trying to make data scientists software engineers.
Right. Yeah. No, that's the biggest thing, right? Like we got to keep people close to their disciplines, but still integrate, right? And that's the struggle. That's where teamwork comes in, right? To figuring out where the boundaries start and end for each individual team or person or whatever it may be. But just get everybody in the room, right? Like have everybody needs a seat at the table. Everybody needs to have that, kind of equal footing in the room, as it were, to say like, this is what our capabilities are, and this is where we need to be. And figuring out how to get there together is the key, I feel like.
And I do feel like the containerization helps a lot too, especially with running those notebooks. Because like instead of everyone having their own set of things on their local machine, everyone having that common starting point platform for where they're working in Jupyter or whatever helps a lot. And me being able to look at that, containerized image, even if it's just a Jupyter thing, and seeing what dependencies are in that container, helps towards production a lot too. Helps me pick up and understand what's going on.
Thought I heard my dog bark, but no, something else. All right, awesome. So despite the train wreck of my home internet and all that, I appreciate everybody coming on and joining us today. Is there anything else we want to show off before we sign off today, or talk about future shows maybe?
So we'll be back in 2 weeks.
2 weeks or
right, Chris?
4 weeks?
Well, 4 weeks works as well. You tell me.
How often does this repeat? Let's see. I can never remember these things. Oh, I've separated it from the whole thing. Hang on. Every 4 weeks is when the data scientists will come on. But basically, every 2 weeks, the data services office hour will feature storage or science, right? So when you think data, we're going to have every other week. It's going to be alternating between like how to set up the storage, how to build the environment to do these things, and then have the actual data science process happen on the show. So if you're looking for Chris Blum or Bloom and Michelle De Palma, they will be here every other week, and Chris and Sophie will be here on alternating weeks, basically. So it's every 2 weeks for the show, but every 2 weeks it's a different crew. Does that make sense? I probably explained that the most awful way possible just now, I feel like, right? Because I'm so flustered. But anyways.
I think that makes sense. So, once every 4 weeks.
Right. Like, go ahead.
I think for our next shows, I think we got some stuff that people want to see. I think we can look at some data exploration from inside notebooks, some really nifty tools to do that. I think we can show people some of the, the training pipeline stuff that people use to build their models.
Yeah.
And I think we can show them some of those serving things I was talking about. We can show off like Selden or KS serving and see, just to show people the different options. Because this was the drop dead simple option. But like I said, if you're willing to go into those other offerings, I think there's a lot of value there. And they're fun to use.
Correct. They are fun. And I wish I was a data scientist because it seems like a lot of fun. So thank you, Sophie. Thank you, Chris. Thank you, Bobby, for helping out today. Bobby, the intern, saving me yet again. I don't know what we're going to do when you're gone, Bobby. I'm going to be sad. But tune in 2 weeks for more data services office hours. But later today, we're going to have In the Clouds with Kirsten Newcomer and hopefully Andrew Clay Schaefer talking about DevSecOps and shifting left. We are also going to have Dev Nation on the air. We'll have GitOps Guide to the Galaxy this afternoon. We're going to look into Intuit's coming on to give us a deep dive into Argo. And we're going to wrap things up with the another kind of series premiere of the Stack Rocks Community Office Hours today. So stick around, stay tuned, subscribe to the calendar if you're not already, which I'll drop in chat. Oh, Sonny's back. Hey, Sonny, come here, buddy. Come here. Come here. Come here. Come here. Everybody wants to see you. And dog.
Oh, Sonny, hello.
So she looks terrified because I hold her wrong. It's okay, buddy. You want to go get Julie? Okay. Go get Julie. Go get. Shaking off. Don't huff at me. All right. So now that everybody's seen Sonny, we should sign off for the day, and we will see y'all later. Stay safe out there, folks.
Thanks, Chris.
Thank
Bye,
y'all.
team.
Bye.